unmute, share. Okay. And now, there they are. Good. So the remote viewers, were a little bit late because there was a visiting speaker for the biologists, and we had to wait for them to clear out. But okay. So that's the schedule. And I'll just say before I start, if anybody doesn't know, you should know that our team is awesome. We went to the Collegiate Penetration Testing Championship this weekend, and there were 7 teams, all from 4-year colleges, except for us, and we got second place. So we beat UC Berkeley and a whole bunch of other places. There's the team, and there's the only team that beat us was Stanford. Yeah, we beat Cal Poly Pomona, UC Berkeley, CSU, Dominguez-Hill, San Jose State University, and another college whose name I forgot. The promotion of this event is very weak. The webpage has nothing on it. There's no list of contenders. They threw it together in a hurry, and they didn't seem to get the promotional stuff down. So, but anyway, we're all going to Rochester in the start of November for the finals. They're going to compete in the National Pen Testing Championship. So,
how many people are going to be?
10 teams, each with 6 people. And they're all the winners from this. So it'll be Stanford and us. But anyway, this guy at Stanford that head of this team took us more seriously after we scored number 2, and now he wants to partner with us. So he says, well, Stanford's not that far away. We should work together. So we'll see what we can do. But anyway, that's good. So it kind of puts us on the map. And this weekend is the CCDC starting, which is the most important contest to get a job. That is the defense competition. And we're going to be doing it this Saturday and once a month thereafter. These are the invitationals, so they are just practice sessions that don't really matter, but they help you get ready. And in January or February comes the real contest, which is regionals, and then the winners of the regionals go to a national championship. So we'll see how we do. Yeah, I showed up early, and this was the guard was asleep, so I thought that was pretty. That was their physical security. I was the first guy there. I was like a half hour early, so it was super early in the morning. Maybe it all started at 7 in the morning. So I was there at 6:30, and their guard was sleeping. So it's pretty funny. Anyway, I could have totally got in. Yeah, they had it at Uber. You were supposed to have it here, but the management totally jerked me around, and I was unable to make that work. And so I told them at the last minute, I guess we're not going to have a regional because you were counting on us to have it, and I was unable to get it through the management. And Uber stepped in and saved it and got it ready in like just a few weeks. So they were just scrambling to get it ready. And it was actually quite good, although I was impressed by this. The original plan was to have a network that would have like 9 Unix servers and 9 Windows servers they were hacking into. And when they booted it up the night before, Amazon ran out of space, which is like mind-boggling. So they had to settle for just the Linux machines. They couldn't start the Windows machines because they had 25 teams nationwide in all 3 events, all synchronized, and each one of them needed like 50 servers. 9 Windows targets, 9 Linux targets, and 6 Kali Linux attackers. So what is that, like 300 gigabytes of space times 25, all starting at once. And that was more than Amazon had. They couldn't launch that many machines so fast. I thought nothing could swamp Amazon, but it's like a city. But Amazon hosts most of the web, some large portion. So they have a lot more space than that, but that's all house owners, permanent hosting. We used up all the rental space available on Amazon for immediate short-term deployment because you're only going to run those machines for 8 hours and then turn them off. So that's why I think if you have a big football game in town, you can easily use up all the rental housing. You can't possibly use up all the housing in the city, but you can easily use up all the rental housing. And that's what happened to Amazon. Anyway, so
I was watching a Black Hat session on this guy doing social engineering.
Yeah.
And he's like, I get in 100% of the time. So he goes into this big corporation, and it says on his tag, "Your computer technician." Like and he got in every door, everywhere you could imagine, just by being, like you're saying, suave and like really smooth. And he did an hour talk on it. It's amazing.
I've heard this many times. The professional penetration testers have a success rate of 100%. They always get in, and they always become the domain administrator. And if they don't, it doesn't mean you're secure. It means your penetration tester was an idiot. And therefore, some people get fed up with it. Like Brett Harden was a pen tester for years, finally quit and said, this is kind of stupid. But the fact is, nobody is secure. As anybody can tell you, Equifax gets hacked, the NSA gets hacked. Everybody is hacking everybody. You can spend all the money in the world to protect yourself, and you still will get hacked. So the game has changed from prevention to incident response. Now you just accept that getting hacked is part of business, just like having fires is part of business, having sick employees, having employees that steal stuff from the company. All these are just things that are going to happen. And instead of pretending you can prevent them, you figure out some response to limit the harm they do. It's like, you know, you have fire alarms and fire drills because you can't totally prevent the fires. Hacking is just the same. It's just going
to started. I'll call you later.
Layers of defenses and detection and response teams to cope when it happens. Yeah. So yeah. So anyway. So let's go up to our chapter here, which is about enumeration. These guys have tried to make a sort of science out of hacking. And so they've broken it up in these stages, which seemed kind of artificial to me, but I must say I'm getting more sympathetic to these stages as I get involved in real penetration testing. The team there actually made a flowchart in Visio that was really quite sophisticated. First you scan the network, then you do enumeration steps. So this is one of the steps. So the idea is we'll talk about enumeration and then details about how you do it against Windows and Unix. So enumeration is what you would do. First, you do footprinting from the outside, where you look up information about the company on blogs and the website and news articles and something. Then you do fingerprinting, where you do scans of the servers and find out what they're running and what version of things they're running. And the next step is enumeration, where you now discover that they have something like a file server, and now you're going to get a list of all the account names and all the folders and files and all the users in Active Directory. You're going to get a list of all the objects available to all those services. That's the next step. And because first you find, from the outside, you find like IP addresses that might be worth attacking, for example, and all, of course, more information. Then you find specific services and versions that are running that might be worth attacking. And now you're going to find specific objects in those services, like email accounts in the mail server, login accounts in the domain controller, file shares that are available. And this is just more and more information about the company. And now you can try to get in with various techniques. If you find a bunch of user accounts, you can see if some of them have short or obvious passwords. Like one common name, one common account is the Joe account. They call it the guy that has a password equal to the username. A lot of people do that, so it's very easy to test, and you try simple things like that, and you might very well find a way in. Anyway, so this is the game. Now you also get the network topology and so on. So port scanning and footprinting came out before. This is pretty intrusive now. Now you're connecting to servers and downloading information from the servers, whatever you can get. But see, most servers have layers of authentication. For example, you can connect with usually no credentials at all to a file server and get a list of the available files. Then if you try to download a file, you might have to have a user account. But usually you can at least see them to see what's there without a user account. So in the early days of computing, there were separate protocols for local area networks and wide area networks, just because all there was at first was local area networks. So people had silly old protocols like IPX, SPX, and AppleTalk and stuff, just to get computers in one room to talk to each other. And one of them was this NetBIOS. Originally, there was the BIOS in your computer that when you boot up, detects the floppy drive and the RAM and stuff to get started. And then they made the NetBIOS that would detect your local networks. It would find out if you had a shared printer or something and let you connect to it. And it was a very simple protocol, very old, designed to run on really old, slow networks, and designed to run on really stupid networks. So every device just had an alphabetic name, like you see here, Sam Laptop and Rick HP and Sam P4. Those are the real names, no IP addresses or anything, just alphabetical names on the things. And you refer to them by that name, and they address packets by that name. That's called the NetBIOS name. And that was a system that really worked for small home networks and small business. You just call it station 1, station 2, printer 1, printer 2. But when you connected to the internet, there would be 1,000 printer 1s and printer 2s. So you had to have this IP address stuff, which was perceived at first as something very complicated and confusing and far too difficult to use on a home network when you just want to give them names like that. And what we're actually using now is NBT, NetBIOS over TCP/IP. Originally, it was its own protocol, but as the internet came out and everybody had to learn TCP/IP anyway, everybody decided to just use TCP/IP for the local network too. And so they continued to use NetBIOS, but now it's actually transported over TCP/IP, so devices have both IP addresses and NetBIOS names in Windows networks. And you can refer to them either way. So there's a tool called NBTscan that you can run from Linux that will give you the NetBIOS shares, and there are Windows tools that will do it. These are not hacking tools particularly, they're just how you connect to a shared folder. or a shared resource like a printer on a Windows network. And typically, the whole reason you make a network is because you want to share something like folders or printers, so there's usually some shares flying around. So if you want to enumerate Microsoft operating systems, and especially to find their vulnerabilities, you need to know the history. And that's one thing about this is I tried to take out the old projects that are obsolete, but a lot of things never become obsolete. So you will see that even if you want to not learn about DOS and Windows 95, you're wrong, because people are still using it. One group of people that's using it are other countries, where they're using cast-off computers 2 or 3 generations behind. But unfortunately, another huge category of people using it are Internet of Things devices. There are gadgets that were built 20 years ago and are still in use. And of course, the computer is running something like MS-DOS, because that's all there was back then. Computers, people have like ADHD. Every 2 or 3 years, they have a new version and they want you to throw away the old one. But there's a lot of equipment out there that's expensive, and they design it for 10 or 20 years of service. So the computers in that stuff are 20 years out of date, and they're often doing really important things. So anyway, that's why it's good to know the basics of old versions. So Windows 95 was the first version of Windows that did not start with DOS, which was the command line only language. It was originally QDOS. This was Bill Gates' genius. Bill Gates figured out that when IBM made computers, they didn't have an operating system for it, and they came to him, and he didn't even have one, but he promised to sell them one, like next month, for a few $1,000, and in the meantime, he went and bought one. And it was called QDOS that somebody else wrote. It was like a beta test, incomplete product called Quick and Dirty Operating System. So he just renamed it MS-DOS and sold it to IBM, and that became the piece, and he sold it at a loss. And IBM did terrible things to Microsoft, and they put up with anything because he knew that in a few years, they will need us, and then we can charge any price we want. That was his business genius. He said, I don't care if I lose money on this deal, because it puts me in a position where the whole world will need me, and I'll get a ton of money later. And that's exactly what happened. But when they tried to go to Apple first and buy something from them, and Apple just threw them out. They said, you guys are squares, you've got lawyers, you have ruinous agreements, you're not going to pay us enough, you're just a bunch of bums, get out of here, we're going to make our own computers. And of course, they did pretty well too, but they didn't make the killing as fast as Microsoft with their DOS. Anyway, so DOS went for a long time in many versions, and then Microsoft had Windows 3.1, which was really like a video game that ran on DOS, made little cartoony graphics for the file manager and such. And then they finally had Windows 95, which was the first thing that was not really running on top of DOS. And so this added a few new things. Introduced the registry. As you know from what little you know in Corley in this class, and you may have used Linux before, Linux, every program you install is separate from all the others. If you install Apache, it has its own Apache configuration files. If you install something else, it has its own configuration files. So the configuration for software is just scattered all over the disk. Each developer of every package just makes some text files with whatever the configurations are, and you have to research that. And they're not really very consistent. They're not all in one place. Microsoft didn't like that. So that's how they did it in DOS, but in Windows 95 in the future, they invented this thing called the registry, which is a binary database, and in there are all the settings for all the Windows components and all the installed software, all in one object. So that started here. That was, in the old days, they had win.any, autoexec.bat, and configuration files all over the place, just like Linux does. They also had plug and play in Windows 95, this is kind of funny because I didn't notice it working until Windows 2000. But this is the usual way it works. When Microsoft has a new feature, it's not really any use until the next version or the version after, because in the first place, the early versions of it are usually really buggy. And in the second place, if you're going to do something like plug and play, the point of plug and play is you can plug in something like a printer and it will automatically load the drivers. Well, that only works if the printer manufacturer has built their product up to Microsoft's latest standards, and they don't usually, and customers buy old things, so it won't, you won't really get any benefit from this feature until everybody catches up with it. And this used the FAT16 system. The original file system was FAT12 for floppy disks. FAT16 was for hard disks, but it was very limited. You could only go up to a 2 gigabyte partition, which was a lot back in these days when you couldn't afford a 2 gigabyte hard disk. But before long, people could afford 4 and 8 gigabyte disks, and then they were really irritated by having to break them up into 2 gigabyte chunks. So Windows 98 came out. It fixed some of the serious problems of Windows 95. Now you guys don't look old enough to have lived on Windows 95, but man, it was amazing. Every 2 hours, it would die with a blue screen of death. It had memory leaks. You'd just be working and it's dead on you. You lose everything. So Microsoft responded to this in classic fashion. They couldn't fix the bug, so they added an auto-save feature to Microsoft Word, so it would automatically save your document every 10 minutes. So you wouldn't lose as much when it died under you. And it wasn't until Windows 98 second edition that they finally found the memory leak that was making it crash every few hours. So, you know, this is why the Linux people really had an attitude in these days. They said, this Microsoft stuff is garbage. You're an idiot for using it. If you use Linux, it would stay up for years and be much superior. And they were kind of right at this time. But anyway, it was much easier to use. This introduced FAT32, which would let the disk get really big. And Windows ME, Microsoft has made a few products that they deny knowledge of later. It's kind of hilarious. If you look at the Windows family, Windows ME is not there. They sold it. It was the Windows 2000 version. What happened is they had a home line that was still more or less based on DOS. And they started in 1993 a professional line for business called Windows NT. And when they reached the year 2000, they made the upgrade of Windows 98 was Windows ME for the home users. And the upgrade for professional users of Windows NT was Windows 2000 Pro for the professional users. But the Windows 2000 Pro was much better than any previous Microsoft operating system. And there was a lawsuit at the time claiming the reason it got better is because they stole a lot of code from Linux, which appears to be true, but they quietly silenced that lawsuit. But anyway, it was really a whole lot better. And so they abandoned the Windows ME product. Before finishing it, it was a beta version. This is what my Microsoft insiders tell me. And then they just sold it to people without worrying about that. So it was one of their fantastic flop products. It was the supposed upgrade of Windows 98. People hated it. And so then they don't even acknowledge it in their list of Windows versions anymore. They pretend it never happened. Yeah?
Was this version particularly useful for because I noticed in the medical field, they have this OS on everything.
Windows ME?
Yeah, Windows ME.
Boy, it was never intended for that kind of use. But I think Windows 98 was built in a lot of equipment too. So I think what happened is this was the first operating system that was powerful enough to put in all kinds of gadgets. And so people started putting it there, and ME was the upgrade. But certainly Microsoft would rather have used NT. I would think that would be much better to build your gadgets. But you're right, a lot of gadgets use the Win9X system, which is now completely dead. This was the end of it. So all those devices have been abandoned, like what, about 20 years ago. So and at this time, Microsoft had not the slightest pretense of security. Windows 98 had a login screen, and if you didn't have a password, you could just close it and use the computer. The only purpose of the login screen was so people could share it like in a family. You could log in, and then you'd see a different desktop, and you'd see your email. And then when the other members of your family logged in, they'd see their email. It was not intended to deny anyone access to the computer for not having a password. It was just a way of sorting the desktops and programs and emails and documents folders. They don't even had documents folders then. Back then, you just put everything in C. I remember we'd make C Sam and C Joe and C Betty, and everybody put their files in there. It was really, really primitive by modern standards. And there was no pretense of security because there was no internet hardly. There was nobody thought about hackers. It was like an appliance, like a toaster in your room. If you were in the room with it, that meant you were allowed to do anything with the computer. Anyway, so like I say, TSA baggage scanners are one of the many products that are based on Windows 98. And Billy K. Rios is one of the security researchers that analyzed these and found out that not only are they using Windows 98, but they're doing many, many other things. They have hard-coded passwords you can't change, so they're the same on every box, and so on. Because the people that built the scanners are just thinking about how to build the X-ray and how to detect the gun, and for them, the computer is just an annoyance. So they just have some guy make the computer easy to use, make it just automatically log in or something. I don't care about that. We're working on the other parts of it. And we assume that it's going to be operated by a TSA agent standing there. So it's not like someone's going to have any chance to hack it. It's just supposed to run the device. Same thing with voting machines and everything else. They don't think it needs to be secure. Same things with medical devices. The people that designed them did not have any concept of computer security. To them, the computer was just a added little gadget to make it work a little better. And it wasn't until much later that anybody asked, did you introduce a security problem by adding that computer to the gadget? And of course you did, since you added the computer in a very sloppy, thoughtless way. But the people that designed it did not think of the computer as in any way important, just a minor incidental part of it. And securing it was nowhere on their menu.
They had the voting machines that I was reading, once they got into the room itself, the hackers were really good. 10 seconds to get inside that box.
Yeah.
Pick the lock.
Yeah.
And about a few minutes to change 20,000.
Yeah, and that was the report today. They just published today the DEFCON report from the Voting Machine Village. And by the way, I think that probably has to do with all the voting machines that became available. We have one now. It's in 215. They gave it to me at Cactus Con, and I shipped it here. It got here last Thursday, so we can start playing with it. The voting machines used to be illegal to have, but they figured out somehow to get a few of them available. Anyway, so Windows 3.5 was this was Windows NT. This was in 1993. This was Microsoft's giant leap forward, a whole new operating system, finally not based on DOS at all. So this is where they invented domains and domain controllers. And that was why they thought of it only for business users. You would buy, if you had 10 workstations, you would have to buy an 11th computer that would be the server, that would be the domain controller. And nobody is sitting at the server browsing the web, opening Word documents. All it is doing is running the network for the others, which turns out to be super important for companies, because if you have a company, you have, say, 10 computers, then you hire new people, and this new guy needs an account on every machine. And then somebody quits, and you want to cancel their account on a machine. And then somebody has a new version of software, and you want to make sure that every machine has exactly the same new version of everything. So for this, you need a central point of administration. In the old days, you would just run around machine to machine with a floppy disk and a piece of paper with new accounts to make, and what would happen invariably is you wouldn't really be able to update the software on every machine and the accounts on every machine, and after about 6 months, your network is just total chaos, and people can't log in where they need to log in, and there's extra accounts you forgot about, and it's just a mess. So that's what this does. You have a central machine, which is the domain controller, and you make every adjustment there, and it propagates to all the domain members over the network, so you can push out software update, and all the accounts are made there, and all the security is controlled from a single point, so you can put permissions on a folder, and they apply to everybody in the whole domain, which is the whole enterprise. So that was a big deal. And to do this, they had to greatly increase the quality of their product, so they wrote Windows NT. And they also improved it by adding this NTFS file system, the new technology file system, which added all the features. See, FAT12 was for floppy disks, and there were no access controls at all, because simply having the floppy disk in your hand constituted permission to read and write everything on the disk. That's how it was designed. It was an object, like a dollar bill. But and that was the same thing for FAT16 and FAT32, but NTFS now had a whole database that can store a record of information with each file, so it can have a long list. Administrators have full control, users can read only, Joe's not allowed in here at all, Sally has full control. You can have a long list of access controls for every object. So that was the big thing that's only possible with Windows NT, and all modern versions of Windows are in this family. The Win9X family died out back in 2000. So Windows 2000 Server and Professional are the server and client versions of Windows 2000, which was the upgrade of Windows NT, and this is when Windows really started working well enough to run for business. All versions before this were just appalling when you ran them for things like web servers. They would just crash all the time, have huge security problems, get hacked all the time, and the Linux people had this giant attitude about how they were so much better, because they really was much, much better on Linux at that time. So this brought out Active Directory, where you can store all the directory objects on the domain controller, like the printers and everything. And that was based on Novell's directory service. Back before the year 2000, Novell really ruled servers. And they had like 80% of the server market back in the early 90s, but they totally did not give their customers good service, and they fell like a stone. And Microsoft's imitation of Novell's network is what actually took over, which is their Active Directory. So Windows XP was the upgrade of Windows 2000. And it was by far Microsoft's most long-lasting, most popular operating system. It lasted for like 12 years. Everybody loved it. People got used to it. Boy, when it first came out, they screamed, this is a waste of time. It's just useless eye candy. Windows 2000 was fine. Then after a couple of years, they forgot to complain, and they all got to love it. In Service Pack 2 is when Microsoft finally discovered security. Until 2002, Microsoft had an official policy of ignoring security completely. What they said was, because they were designed for local area networks, not really using the internet for much of anything, they said there really are no hackers to worry about. All you have to do is make something that will work if a user is making an honest attempt to do their job. So you want it to survive honest mistakes, but there's no point thinking up exotic attacks and making it strong against them, because that's not going to happen anyway. That just wastes everybody's time. What they want is more features for them to use. But in 2002, they finally realized that it was no longer possible to carry on business that way, because everything was getting infected and hacked. So they added a lot of security to it in Service Pack 2. And these are the big ones. Windows File Protection is a system, a very simple system, a little bit like Tripwire, that you can run to verify all the critical system files and see if they've been altered and put them back in their unaltered condition. So it'll remove some malware that alters system files. Data execution prevention lets you mark areas of RAM non-executable. So you can put passwords and data in a block of RAM, and if somebody finds a way to inject code there, it won't run. So this blocked a whole category of buffer overflow attacks, which were the most common kind of attack at this time. And the Windows firewall was a real firewall built into Windows. Before this, people would have to download third-party things like Zone Alarm, and most people didn't. And now you had a firewall, so services that you were not using were blocked, so people couldn't get in your machine. The Windows firewall turned out to be amazingly effective. There was an independent test years later, and they showed that if you connect a machine to the internet and do nothing, without Windows firewall, it will get infected in 1 day. And if you just turn on Windows firewall, it will take 1 year to get infected. So it really makes a big difference for your security. And this was the Trustworthy Computing memo in January of 2002. This was Bill Gates' memo changing the entire premise of Microsoft's philosophy. So instead of ignoring security and focusing only on features, they were going to make security first, even when that made the products more difficult and complicated to use, which was a big business decision, not arrived at lightly, because that's going to cost them a lot of money. Before this, they were competing with Apple. And Apple's main thing was that they were easy to use. You didn't have to read a manual. You didn't have to take a course. They had the mouse and the beautiful monitors, and you could just draw stuff, and it was like using a pencil on paper. It was easy. And Microsoft was always trying to say their products were as easy as Apple, which they weren't. And at this point, they pretty much had to abandon that and say, you know, now it's going to be hard to use our products because of all this security, and you're going to have to take a class and get a certification to run the server and all that jazz. And that was an unpleasant business decision, but that's the decision they made because the malware situation was so terrible that people were not willing to put up with Windows being as insecure as it was anymore. So Server 2003, Microsoft always brought out a server and a client product at the same time, so they would go together. So it was XP and Server 2003 came out together. And Server 2003 had Service Pack 1, which was the equivalent of Service Pack 2 for Windows XP. That was the service pack that put in all the new security features, like the firewall. And then Vista came out. This added user account control, which is one of the huge things that the Linux community had been sneering at Microsoft about for years. Windows XP, you would typically log in as administrator. Then you would open Internet Explorer and browse the internet all the time running as administrator. So if you find an ActiveX control on a web page or something, you could just install software or erase files and everything on your machine. And the Linux people would be sneering at you, saying, you know, you shouldn't be running as root when you're browsing the internet. And Linux, for 10 years before this, had a system where you run with low privileges and you only escalate to privileges when you need them. And that's what Microsoft finally put in Windows Vista. It was very secure, but it was very hard to use, very irritating, so everybody just turned it off. So it didn't actually accomplish much good in Vista. They also put in BitLocker encryption, but they made it super expensive. You could only get it if you got the $600 ultimate version of it, so that was kind of useless. Address space layout randomization, however, was a huge leap forward. Now, instead of just loading every program in the lowest memory available, it would randomly choose a location of memory for everything. So the operating system might be in a low memory. The next time you reboot it, puts it up here, and the antivirus is down here. It jumps around. So each program has to be recompiled to be portable executables, and they all move randomly on every reboot. So an attacker that manages to inject code doesn't know where the code is. They don't know where they are. That slowed down, again, the category of buffer overflow exploits, which was the most common attack at this time. The combination of data execution prevention and address space layout randomization caused buffer overflow exploits to decline from like 80% of the attacks down to like 20% of the attacks. It caused the whole generation of malware before this point to stop working, which was the point. It was a really good defense. These defenses are global. These defenses will protect you even if you're running an old program. It's rare that you find a defense that will do that. Anyway, so that was a big deal. And in fact, they have the Pwn to Own contest at CanSec West in Toronto every year, where the best hackers go and they compete to own the latest operating systems. And when Vista came out, for the first year, they could not get in at all. There was no hacker in the world that could get in anymore because all the XP attacks didn't work anymore because of ASLR. It took them a whole year, 2 years, to catch up and finally make attacks that worked. So it was very good, greatly raised the bar in security. So I don't think I'll demonstrate this. I don't even know if I have a good Vista machine to do it, but you can, if you use Process Explorer, you can see where things are in memory. And I think I ran this on something like Vista. So if here's Explorer.exe, which is the main Windows process that draws the desktop and the start button, and everything you launch is a child of the Explorer process. And the Explorer process here loads, say, ntdil, and you can see its location. It's at 76db1000. That's the memory location where it loaded. And when I restart the machine and look at it again, it's now 77d4000. So that's what I mean. Every time you restart the machine, it takes all the programs and just shuffles them like a deck of cards and puts them in different locations. So if an attacker manages to inject code, then they try to jump to the code, they don't know where to jump. They don't know whether they're here or there, and so it slows them down. Yeah?
So has there been any example of an attacker injecting bad code into ASLR?
Oh, yes. Oh, you can defeat it. If you take the exploit development class, we go through this. For every defense, there's always an attack. In fact, what's funny, the DEF CON proposal CFP says, if you have an attack, tell us what is the defense that would stop your attack, and then what is the better attack that would go through the defense. If you have a defense, tell us what attack would get through it, and what defense would stop that. That's the way it always is. So there's several ways to get past ASLR. The simplest one is not every process uses it. Some of them are always in the same place, so attack that one. Another one that's even more awesome is it turns out whenever Microsoft has a defense, they always only do half of what you think they're doing. So notice that this is not really random. 76db, 77d4. The last 4 hex values are always 0. And the first one is apparently always 7, and the second one seems to only go from 6 to 7. You get a clue there's not much randomness there, and there really isn't. In fact, there's only about 8 bits of randomness. So in fact, all you have to do is run your attack about 300 times, and you'll sooner or later get lucky. And there's another one, which is bloody awesome. You make attack to a browser, you run JavaScript, and you make an attack that has a huge NOP sled, like 10,000 copies of NOP and then your egg. And then you just put copies of it in memory to where you fill all of memory with it. Thousands and thousands of copies of your attack, and then you just jump at random and hope to hit one. And you can get the odds like over 90% that you'll hit one by just filling the whole memory space. So there are ways to defeat ASLR, but it did, slow things down for a while. That's why every defense, there's nothing perfect. Every defense just means the old attacks quit working, and it takes people a couple of years to write the new attacks. That's all you can ever have. All right, so let's see if I get this thing to move on me. All right. So let's see, ASLR, here's Windows Server 2008. What have I got? 8 minutes, I think we'll be all right. So Server 2008 is the one you're using in this class. It is the version that I was able to make a good copy of to replace the XP and 2000 machines I used to use years ago. So here we have user account control. It's on the server the way it's on the client. You have drive encryption available, although it's not that important for servers usually because you're usually not expecting someone to steal the entire server. It's mainly for laptops. Then you have network access protection, which gives you some control over who's connecting to it. And they have server core. Microsoft, another thing that the Linux people had ahead of Windows is you can make Linux really, really small. Like they're Linux that fits on a floppy disk. So if people take Linux and strip it away and make a little tiny fast system that just does one thing like a web server. And Microsoft wanted to be able to do that. So they made a server core version that is really small, has no graphics. Most of the features are removed. It can only do a few things, but it can be a domain controller and a web server and stuff. And they recommend it. And then they also had Hyper-V, which is their ability to host virtual machines in the operating system, which was not very powerful in Windows 2008, but it improved in later versions. And by Server 2012, it really started being an enterprise class client like VMware's ESXi. So Windows 7 came out. This was the big step forward, very popular. User account control was made easier. And you all got a free copy of XP in a virtual machine with Windows 7 so that anybody that was worried about compatibility could run their XP software. In fact, almost nobody needed that. Almost all XP software runs flawlessly on Windows 7 because Microsoft put a lot of work into putting compatibility features into it so software will feel like it's still on XP. And you can install old versions of things written for XP on Windows 7 and they run. Windows 8 was this thing with the appalling graphics problem where they tried to make your desktop look like a cell phone, which was sort of insane and drove everybody nuts. But it did have a lot of good features under the hood, like a built-in antivirus, although it turned out to be very, very weak, lame antivirus, but it was the first time you actually get antivirus without having to add it later. And it had a much more vigorous anti-phishing system where it would block known hazardous websites. So when you try to go there, a big screen would show up and stop you from going there. And it had this feature which Microsoft had been trying to implement since Vista, where it will verify the integrity of the operating system on boot up in the BIOS, and not load if it's infected with a rootkit. They promised to do that on Vista, but Norton sued and said you're destroying the entire antivirus industry by doing that, and we will sue you for antitrust. And because Microsoft nearly lost the entire company from antitrust lawsuit over what they did with Windows 98 to fight AOL, they were afraid of an antitrust lawsuit, and so they delayed this feature. And on Windows 8, it only applied to their Windows ARM tablets, which never went anywhere. But this is where you replace BIOS with the EFI system, extensible firmware interface or something. And with that system, you can check a digital signature of the operating system kernel during boot up, and you can tell if it's been altered or not. And that would prevent all rootkits, but it would also prevent anybody but Microsoft from putting code in the kernel. And antivirus, as it's currently written, has to get in the kernel. And if that's possible, then Microsoft cannot verify the integrity of the kernel because they do not know what it should be. Other companies are changing the kernel. So in a way, that's why a lot of people get an attitude. In a way, antivirus makes you less secure. But in most cases, it's better with antivirus than without antivirus. But especially when you get down to this level, there's an argument that you should really make something and not let any virus in. And that's what Apple did with the iPhone and the iPad. You can't put antivirus on it. You can't put a firewall on it. You don't need it. They made it secure in the first place. Yeah.
So, just real quick, is it even worth having Windows Defender on?
Yes, Windows Defender will stop some attacks. And it's pretty harmless, but it certainly doesn't replace antivirus.
Yeah.
They recommend you go get something else like Kaspersky or AVG or something. Although lately they're mad at Kaspersky for pretty good reason. But anyway, I don't think individuals have much to fear from Kaspersky, but military and government people are not supposed to use it anymore for a pretty good reason. Anyway, so Server 2012 finally dealt with pass-the-hash attacks, which are hilarious, and we're doing them in the advanced hacking class. You can steal password hashes and log in with them without doing anything else. It's kind of ridiculous, and Microsoft created these siloed accounts. So you can make, ever since Windows 2000, they've said that all administrators should have two accounts. They should have a domain administrator account and a non-domain administrator account, and they log into all the workstations with the low account, and the privileged account they only use to run one command at a time on the domain controller. That is what they tell you to do, but they didn't force you to do it, and so nobody bothered. Everybody was logging as the domain administrator all over the place. So sessions with domain administrator credentials and copies of the hash domain administrator credentials would just be all over the place. So then when somebody gets a workstation infected, hackers can find those credentials and steal them. So siloed accounts actually cannot be used except on the domain controller. And they force administrators to have two accounts and only use the highly privileged account on the trusted environment. That's the idea. They also have DNSSEC. We're going through in a DNS class, which is an encryption routine to make DNS more reliable and safe, but it's really not doing anybody any good yet. It's gradually rolling out, and it won't really be of any great benefit until about 10 years from now after everybody starts using it. And then, of course, Windows 10. Windows 10 finally brought the start button back, so the experience is almost as good as Windows 7 instead of just making you want to smash your computer, which is what most people felt like trying to use Windows 8. And forced automatic updates that are very difficult to turn off, which is very questionable considering how lousy Microsoft's updates are and how often they make trouble, and various other new things here, reducing the risk of pass-the-hash attacks, supposedly. And Windows Server 2016, which now has Docker containers on Windows, where containers are like virtual machines, but they are much smaller and much faster because they do not really isolate the VM from the host. They use files on the host when possible. So if you put a Windows container on a Windows host, it's like 20 times smaller and 20 times faster. So you could run like 100 containers on a machine that could only run 3 or 4 VMs. And Microsoft is building them into 2016. But it's the new feature and not that commonly used yet. So I got some cahoots, and I'm going to stop and restart the share because it's timing out. So you guys come back. All right.